Hi everyone. So today this session is scheduled to this specific issue, specific defect that we have seen in iOS XR from a specific release on Inter-AS option B. And this is not a PI session. So, but still I have given some brief, and there are a couple of footnotes also in the slides, which will take you to good articles inside like in tech zones and also external. So 4264 lists the three options which are which briefs on how you can do L3 VPN service across different autonomous systems, and they are listed as A, B, and C. So A, B, A is straightforward. You use VRFs on the back-to-back ASBRs to to preserve all the VPN v4 information across the AS. It's a difficult option to scale. It doesn't scale really well, but it's easy to deploy. Option B, uses the eBGP VPN v4 MPBGP address family to send the VPN v4 routes, exchange VPN v4 routes across the different autonomous systems. And then you have option C, which is actually taking care of the appearing in multi-hop eBGP appearing in between the VPN v4 routes, and also it takes care of the transport label across the different autonomous systems. So just to give a brief of the specific option B, because we are dealing with option B in this defect. You can see here there are two autonomous systems listed, 65,001 and 65,002. And so C1 and C4 consider they're part of the same customer. So when C1 would try to reach something on C4, B1 would actually need to pass the packets to ASBR1. ASBR1 would in turn pass the packets to ASBR2 and then to P3. ASBR1 and ASBR2 would be aware of each other's VPN routes by the use of eBGP VPN v4 address family. And so in this case, the ASBRs are actually working kind of like not a route reflector. It does not really hold, doesn't really, there are no mandates for the ASBRs to preserve any of the routing informations in the VRF. You don't even need a VRF to be instantiated in any of the ASBRs. The ASBRs exchange the information over the directly connected link. It sends it to the IBGP neighbors within its own autonomous system, and the ASBRs always acts as the next hop. So it uses the next hop self property for all the other provider edge routers within its own autonomous system, right? In this case, the route filtering on the ASBRs, you can see point number 4, needs to be disabled. So even if these are not import candidates for into a specific VRF, the ASBRs should not filter them out, should still hold those NLRIs to be passed into, to be sent to other IBGP peers, right? This is just a reference of how the control plane would look. So if you look at C2, which is trying to get a VPN v4 prefix, right? An IPv4 prefix 10.4.0.0/16, that subnet, which says hosted across C5. So C5 passes the information to P3 on the right. P3 gives it to ASBR2, right, which is labeled as P22. ASBR2 will pass this information over the eBGP session to ASBR1, right? And ASBR1 then passes the information to P1. So ASBR1 passing the information to P1, in this case, P1 would see ASBR1 or labeled as P11 as the next of self for the prefix. P1 installs the route in its VRF. Um, and once there is a packet which is coming in to P1, P1 will use the labeling protocol, the top label, whatever it is using within its autonomous system, to reach ASBR1. Once it reaches ASBR1, ASBR1 would be forwarding a VPN v4 labeled packet to ASBR2. You do not need a transport label on this link, on the link which is labeled as MP-BGP in between ASBR1 and ASBR2. So you can just send a VPN v4 label packet to ASBR2, and ASBR2 then whatever the destination of the IP address is of the packet is, it should know it via the internal MP-BGP session, and it should send it to P3. So this is one of the points that you do not need to be worried about the transport levels across the autonomous system boundaries. The ASBRs within the P routers and the ASBRs within the autonomous systems, they will take care of their own transport. And in between the ASBRs, you can just send VPN v4 label packets. Just a couple of notes on interface option B. So RDs and RTs will have global significance. As you can see, ASBR1 and ASBR2, these are part of different autonomous systems. Since they are receiving the VPN v4 routes from their own IBGPPS of their own autonomous systems. So now RDs and RTs become significant across the service providers. Only one link or sub interface is sufficient, right? I do not need LDP, IGP, or any VRFs on ASBRs. Okay. And the rest of is basically what I said, like ARF or automatic route filtering, because the routes are not part of any routing table or not candidates for any routing table, should be disabled on the ASBRs so that it retains all the information. Okay, so this was the trigger in the customer production device. They had ASR 9Ks which are acting as ASBRs for their autonomous systems, and they upgraded the device to 732 EXR, and they started facing the problem. Okay, so this in this slide you'll see the ASR 9K, the problematic device referred to as ASR 9000-1. This is just for in the later slides, while I will show you the lab topology, that is what I named the device to avoid the complexity of specific host names. So consider our device ASR 9001 acting as the ASBR. So the AS is specific, doesn't really matter. So for the customer AS was 19,114. It was receiving the VPN v4 route from this external AS, and it did had VRFs on the device, which is not required. It did have VRFs, but they were not actually importing any of the routes into those VRFs. So there was no matching RT, and ASR 9001 was acting like, as the interface option B goes, it was acting as a next of self for any other IBGP that it is supposed to send the route, send this specific NLRI to. And ASA 9001, which we saw in the problematic state, was not assigning a local label to the VPN v4 prefix that it is acting as a next hop for. So for VPN, for when a device is in the data plane, right, in VPN v4, it means that you'll be receiving that packet somehow on one of your interfaces. And once you do that, there must be a local label for that prefix assigned so that you know what is the forwarding state, like which interface and what is the next hop and all that stuff. But in this case, the ASR 9K was not assigning a local label. And if it is not assigning a local label, for whatever reason, it will not send out the NLRI, because it doesn't make any sense to do that when the device is acting as next of self for the prefix. So that was kind of how the customer started observing. So all the NLRIs from all the routes from the external AS they couldn't reach those prefixes. Any questions up to this point? You can just unmute and go ahead.
I need something like for the document form. Yeah, I have already supported in these many.
Okay, I will go ahead then. So this is the diagram that this is the topology basically used to simulate the control plane behavior. You'll see a footnote here inside the slide as well. So this does not like really replicate the customer configurations values and none of it. Just to get the idea of what is happening in the customer device. So this is where you see the reference of ASR 9000-1. So this was the DUT you will see mentioned above. And this ASR 9001 was receiving the VPN v4 prefix from this peer. It is in AS 26,000. It also wouldn't match with the what we saw in the customer. It was receiving a prefix. You can see the prefix is labeled as well, 126/32. And the important part are the RDs. So you can see the RD, which would be part of the NLRI for a VPN-v4 prefix, is 19114:3000, and on the ASR 9001, which receives the prefix, we also have a VRF, which has the same RD. And please note that the RT that I am exporting on the from the ASR 903-3 device, which is the external AS, that does not match with the RTs of the VRF test on the DUT. So this prefix will not be imported into the VRF. It will just be part of the VPN v4 rib. This slide just explains what I said. It just explains how the NLRI will be formed. That's it.
Hello.
Yes.
Sankhya bhai, in the topology, you have created the VRF on the ASBR also, right?
Yes, correct. Yes.
Just for this like recreation only, right? But in the production, I don't think the VRF should be there.
So in the RFC, there is no mandate of having a VRF. It is not needed. For the customer device, they did have a VRF on the device. The VRF was not playing any role in
Okay, but
importing.
there was no routing protocol between the VRFs. It was like we are exchanging the prefix via VPN before eBGP only, right?
Correct.
Okay, fine.
All right. So all these outputs are from the lab device itself. We just go back. Just remember this part that the DUT had the loop back of 11, 11, 11. So all the 4 octets are 11/32. And that is basically the next hop for the device on the left, 903-1. Basically simulates an IBGP peer. So this device, when 903-1 would try to reach this prefix, it would see 11 as the next hop. Okay, so this output would make sense now. So you can see that. So this was taken on the ASR 903-1. Okay, a debug of the BGP update in command. And you can see that there are repeated withdrawals for this prefix, which is initiated by the DUT of the ASR 9K. Right? And you can see there is a received level value, but then there is a subsequent withdrawal. This part I highlighted. You'll see it says this level value is half of the LSD value of ASR 9 of the 9K. I think XR. And this specific value comes because of a race around condition, which I'll show you later. But just a note, like the label you can see in this output is 24,004, but then it changes. Like you can see the withdrawn label is 524288. Okay. So this is again from the duty. And if you look at the output, you'll see there is a local label assigned. there's a local label assigned. But if you look at the BGP rib in time, you will see it says 136 years and 10 weeks, which is not possible. So and this you'll see in the next slide that this does not really stay like this. It's very short-lived and then it changes. And even coming down, if you look at the received label 16, right, this output received label 16. Um, so this actually is the label that it received from its EBGP peer. You can see the autonomous system 26,000 listed on the top. It received, and just below that where it shows the path attributes, it says that it import candidate, but not in VRF. So the RTs were not matching. So it was not in part of any VRFs. Okay. Now, so this output was taken at 1342 32 UTC, right? So the next output is taken like in a couple of seconds, 1343. And you can see that the last modified time changes from 136 years to all zeros, right? And so this is a critical part. The table version somehow increased by close to 1 million. And I just had one prefix in my lab, which I'm receiving, which is 126 in all the octets. This one prefix is that bumped the table version to this by 1 million. Okay, and there were so this was not seen in production, I believe, the zombies in LSD, but in the lab I found this, and you can see that the number of zombie labels like are like constant. It does never goes to zero. There is technically no churn in the network for LSDs for the zombies to be reclaimed, and you can see the reclaimed value also keeps going up, 417, then 418, right? It's in a constant churn. Once this happens, right, in the previous slides, you saw the repeated BGP updates, the zombies, and then the rib time also changed very frequently. This causes your BGP, a couple of BGP threads to go up higher in processing. So in memory, you will see that actually that will be reflected in the memory detail that this a couple of threads are, and PAM starts showing errors, generating that BGP is hogging the CPU. So that also comes in. Luckily we did not see that in the customer device, but in the internal documentation of the defect, you will see a number of occurrences of this when BU did this. All right. So now so this is a fix which I think was suggested. Yeah, so this was the first fix which I tested in lab, is to import the route into a VRF by configuring a matching RT. And once the route import was done, you can see that the last modified, the rib time has gone up to 18 seconds. So it's kind of stable. And the BGP also in the next output as well, the BGP table version also stays stable. So this output was taken on Sunday, March 6, 1508. So this is a couple of seconds later, a couple of milliseconds later, I believe. And then you can see it went up. The BGP ribbon time went out by 6 seconds. So it's stable, and the BGP table version is also stable. It does not go up. This was the first fix that was actually, it was suggested when I was in call, but the customer had concerns with importing routes, so they didn't do it in the production. The second fix is much more intrusive. So for the second fix, and you'll see it in the footnotes of the slide, I again took back I again changed the RTs. So I again caused the RT from 1383656, and so it keeps climbing up. So at that point, I again changed the RD. So the RD that I was receiving and the RD that basically the RD that was being sent from the external AS simulated by the ASR 903-3 device. I changed the RD on that device from 19114 colon 3002, I changed it to 3001. So once I did that, the observation is same. The prefixes started stabilizing. You can see it's here, it's stable for about 3 minutes and 17 seconds. And but this was the customer wanted to do this actually in the production environment. This is just a subsequent output of the same command. It just shows that it went up from 3 minutes 17 seconds to 3 minutes 29 seconds. The customer wanted to do this. We discouraged them because changing the RD is much more intrusive. It will cause the entire VPN v4 route able to be refreshed. So anyways, they didn't do this one as well, but this was successfully tested. So this replication, all this replication was sent to the DE, and they confirmed that this is the defect which is causing this. So this can only happen in XR versions of 732 and later. And you can see the mentions of high CPU in BGP import and BGP label thread is seen under below conditions. The conditions I got lucky, it matched basically with what the defect said. And you can see using same RD on VRF on one or more remote PEs on and not importing this prefix on the SBR and local VRF with same RD as the remote RD. So that is one of the conditions. It causes a race around condition in the code, and there is a different defect. I have also linked that. So the race around condition which causes this table version to spike up to like by a million with even just one prefix is there only in 732 because they made some changes on how you treat NLRI once it comes in and yeah, is not an import candidate. So they made some changes which triggers a race around condition and thus triggers this defect. Okay. Uh, we raised the SMU, and the SMU was tested in Calo Lab as well, apart from the usual testing done by the devs. And the SMU was implemented successfully subsequently, and right now it's working fine. So all the SMU testing details and everything, like which I did from STTS side, you'll also see it in the inside the slide. Okay. That's
Capturing
about.
all these details, Sankhya. I think this is
Sorry,
also capturing all these details.
I'm sorry, Pooja, I couldn't hear you. Can you come again?
My voice breaking?
It did. Now it's okay.
Yeah, I was saying this is very detailed capture of the Calo and everything. So thanks for that. Guys, any question? Please feel free.
Sankhya bhai, can you go back to the PPT where you change the RT to import it? Like the previously RT was different, right?
Yes, correct. Mm, yeah. So this in this output you'll see this. It says. So
Can
let
can
me
can
check.
you can you zoom in? Yeah. So
Yeah.
like my point is, what was customer looking for? Like earlier, if we do not if we are not importing the RT on the ASBR, right? Our prefix
Mm,
is the VPN v4 bus. Okay.
yeah.
So are they importing the RT on the ASR 9XX device on the IBGP neighbor? Are they importing the prefix directly in that VRF?
Yes, they must, right, for the VPN v4 traffic flow to work, right? So on ASR9 in this topology, so
Mm-hmm.
ASR 9000-1 is acting as the SBR, right? And it does not need to do any imports into a VRF, doesn't need to have a VRF at all. But
Mm-hmm.
ASR 903-1, right, that is acting as a provider edge router for this AS19114, right? So consider there is a customer connected to ASR 903-1, which
Mm-hmm.
is trying to reach a customer which is connected to ASR 903-3, right? So if it is sending a packet whose destination address is 126.126.126/32, the packet hits a VRF, correct? So
Mm-hmm.
once you have hit the VRF, there needs to be a route lookup, right?
Yeah.
And for that to happen, that route needs to be part of the routing table. So
Yeah.
that's for that you need to do a RT import.
Yeah.
So within the AS, right, it's just normal VPN v4 there, and there is no significance of inter-AS. Within the AS 903-1 is only concerned about who is the next hop, whether it has a label for the next hop and a label for the prefix,
Yeah.
VPN v4 prefix. So
And ideally, like I'm not so sure about like how does it work in the production. On the ASPR, we should not have any VRF, right? Even if we have the VRF, so that means the customer already have a CE also there
could
on
be.
the ASPR.
Could be. So the SBR could be acting as a
Okay.
provider edge, but because you don't, there is no need. You do, it's not a mandate. Like on interface option A, there must be a VRF, but in interface option B, you don't need a VRF. If you have it, it's fine. Doesn't really matter.
Okay. Okay. Fine. Okay. Thank you. Thank you, sir.
Sure.
Hi, Sanjay, Tushar here. So in the production network, I think so the feasible workaround is that RT part, right? To import the RT.
Yes,
Because
absolutely.
RT is not a feasible workaround, right? In the
No,
production.
absolutely not. So, but they did so they did not do that, the RT
Mhm.
import. Instead, the customer, they were actually on 663 EXR, I believe. So they degraded the 732 663 EXR till the SMU was prepared by us.
So have you tried to remove the VRF on the ASBR? So
No, so I can do that, but even that would be worse than changing the RD.
no, but that VRF is nothing of use, right? Because you are not importing anything, right, for that RT.
Yes, but in the production, are you asking me if I did it in lab?
Yeah, yeah.
No. I did not try to change that in lab because I had to hit the specific
Okay.
conditions of the defect, right?
Okay. Just I wanted to know because if we remove the VRF, it will not go in the race condition, right? Because
It should not, because
yeah,
now there are no two RDs for the race condition to
exactly.
trigger.
Exactly.
Yeah,
Okay. Thanks.
sure. Anything else from anyone? Just you can go ahead.
Hey, hi, Shankar. First of all, fantastic presentation and very good explanation as well. Can you please go to the defect slide?
If,
So for 660, this was working fine, right?
yes, so I have mentioned this. So this here I've highlighted in green, only present in 732 and later. So later versions, earlier versions will not be impacted.
Yeah. So basically, during that time, we are having two different RDs, different RDs and different RTs as well, right? Or the same RD, different RT.
Same RDs,
RT, different
mismatch of
RT.
RT. Yeah.
Yeah. During that time, the ASBR, whoever is, I mean, that specific ASBR who is actually getting the traffic from the EBGP peer, right? VPN before EBGP peer,
Mm.
is having no issues while, I mean, sorting out this is for a different RD. I mean, that's what I'm just trying to understand. So earlier in 663, same RD was coming in. RT was not importing it, right? So as you have already mentioned, as we know, right, that VRF or RD is not at all important in case of ASBR, option B.
Right.
So in that case, how the behavior is different between this 663 and 732?
So the different behavior is in the code actually on how they treat NLRI, which where there is same RD, right? And the exact there is a code, there is a section within the fix, but I really do not understand what it is. So I will give you that it is present inside this slide as well. Okay, not this defect. There is another one which I have referred to. That actually explains the race around condition, but mostly with pointers and references, which it doesn't make any sense to me at least. But if you want, I can give you the BU contact as well. The very nice guy. He can explain.
You can share this defect. I mean, it is already there, so we can check the defect if we can get. Because I'm just so you mentioned, right? This is only present in 732
And later, yeah.
later, and it was not there in previous releases, right? So there must be some changes, as you have just mentioned.
Yes.
And so either it could be a bad code fix or some other improvements they were doing in the code, then they landed in this scenario, racing condition. Okay, that answers my question.
What I found out from an internal call is they were trying to make something more efficient, but then that triggered this problem, is what I understood.
Yeah, thank you, Shanti.
Sure. Welcome. Anything else? Okay. Pooja, I think we're good then to close if no one has any further questions.
Hey, Sankhya, thanks for this well documented and detailed update on this issue.
Sure. Welcome, Tisha.
Sorry guys, my internet fluctuated. So just reach out to your spokes in your team. Like Sunny is the spoke for APAC TAC, Satya is the spoke for EMEA TAC, and Naresh and Sheila are spokes for SUTS. In case you want to present anything in the further Chalk Talk sessions, and HTs on the different accounts can reach out to me directly in case you have anything which you want to share with the wider audience. And similarly, I'm in touch with all the leads and the development teams as well in case they are, they want to present anything. Okay. Thanks everyone for joining. Have a great day.
Thanks, Pulu.
Thank you.